So in this experiment, you're going to be building 3 different circuits, and the first one looks like this, except that in your lab manual it's actually drawn like this. So I've just turned it all 90 degrees because that's going to correspond more exactly to what I will physically build in front of you. So it's just twisted 90 degrees relative to what's in your lab manual. So what we're going to do is we're going to build this circuit where the power supply is this box here. This is the Xantrex, the DC power supply. So you can turn that guy on right now. And there's 2 knobs on here. There's a current knob and a voltage knob. The current knob, turn it all the way up. So we don't want to limit how much current the circuit can draw. We are going to set the voltage, however. So you take the voltage knob and you set it to 12 volts as exactly as you can. That's a little tricky, but do the best you can with it. We are never actually going to use the numbers on this screen in our calculations. What we do instead is we grab a multimeter and we're going to take all our measurements of the voltage and the current for the circuit off of this. So we'll never use these numbers after you've set them. So I'll show you how to use the multimeter later. So I find with these circuits that it's best just work your way very methodically, sequentially around the loop. So you say, okay, go from this terminal over to the switch. And after that's hooked up, go from the switch to the first resistor. And after that's hooked up, go to the next one, and then to the next, and then hook back to the negative end of the power supply. It's just the best way to keep yourself from getting confused. It's just go through the loop one step at a time, very methodically. Now, there's a whole bunch of connection points down here, and we need to understand those. So first of all, there's 2 on the side that we're just not going to use. You've got a cluster of 3 in the middle, a red one, a black one, and a green one. These are the ones that we'll be using. Now the older Xantrexes require you to connect the green and the black one together. So you just grab a wire and you connect them like so. It's a little annoying, but it's just something we have to do. The red and the black terminals correspond to the positive and negative ends of the power supply in your diagram. So now let's work our way around this. We go from the 12 volt positive end of the power supply to the switch. The switch is this little guy over here, so it's a tap key. So I go from the positive end of the power supply over to my switch, just like in the diagram. Then I go from the other end of the switch to my 50 ohm resistor. So grab the 50 ohm resistor and connect it to the switch, like so. So there's my switch, there's my 50 ohm resistor. Then I go from the other end of the 50 ohm resistor to the 100 ohm resistor. So again, I take my wire and I go from 50 to 100. And by the way, the insides of the wires are all the same, so it doesn't matter whether you're using a red or a black one. You can color code things if that helps you, but you don't need to. Same thing with the resistors. They have red and black terminals. It really doesn't matter if you hook things in backward, however. The current's all going to flow through it in the direction that it wants to flow. So next, from the 100 ohm resistor to the 120. So let's hook that one up. And finally, from the other end of the 120 to the negative end of the power supply, so the black end of the power supply. So from here to the black plug. And now I have built this circuit. So power supply to switch, switch to 50 ohms, 50 ohms to 100 ohms, and then 100 ohms to 120, and then back to the negative end of the power supply. To get current to actually flow through this, you need to push the tap key down. So you push this down, and you can actually see that a number pops up on this current reading now. So we know that there's current flowing in our circuit. To actually take measurements, you will use the multimeter. You'd push down your tap key and take a measurement while it's pressed down. I'm going to show you later in the video how to use the multimeter. So for now, I'll just put this aside. So that's the first circuit. I'm going to show you how to build the second and third circuits also. Okay, so now I'm going to show you how to build the second circuit, which is a parallel circuit. So we've got 3 loops all attached to our power supply. I find that it's always best when you're building a new circuit to just unplug everything, get it all out of your way, start from scratch. You're less likely to get confused about things. Another thing that's useful with these sorts of parallel connections, I find, is just set up the inner loop first. So just set up this loop. get everything connected sequentially, switch, 300 ohms or 50 ohms, and the power supply, then hook up the next loop, and then finally hook up the last one. You're less likely to get confused if you do it that way. Now I mentioned 300 ohms here. What's in your manual is listed as 50 ohms. I've got a reason for that. This circuit and this circuit alone is actually going to run a current large enough to blow the fuse in your multimeter. And there's an easy way to deal with that. If you're using the sensitive scale, you would just switch up to the less sensitive scale. So you would just plug in differently, and that would allow you to measure the current coming out of the power supply without burning out your fuse. There's other ways to handle this. So your lab instructor will tell you what method you're using to try and protect the meters. You can, as I said, just change how you plug into the meter, and you can prevent burning out your fuse that way. Another way is just to switch in a 300 ohm resistor instead of the 50 ohm resistor. The problem with doing this is it makes your uncertainties about 7% rather than 5%. So, your lab instructor will tell you what they want you to do. Either you'll have to be careful to not burn out the fuse, or if you put in a 300 ohm resistor instead of a 50 ohm resistor, it becomes impossible to blow out the fuse, but the numbers you get when you compare things may not agree within 5%. It might agree within 7% instead. So I'm going to move this aside just because it's a fairly complicated circuit. I have left in the wire that connects the green and the black terminals here, and I've got my switch here. So as I said, I'm going to hook up this inner loop first, and I'm going to use the 300 ohm resistor here. So I just say, okay, nice and sequentially, I go from the positive end of the power supply to the switch. So red terminal over to my switch. And then I go from my switch to the 300 ohm resistor, which might be 50 ohms for you. So from there to there. And then I complete the loop, 300 ohms over to the negative end of the power supply. And that's the inner loop of the circuit. Now I want to add the next one. So they say we take the 100 ohm resistor. It's going to be in parallel with the first one, and we hook up the positive end to the positive end and the negative end to the negative end. So we need two wires here. So it's just hooked in like so, just positive end to positive end, negative end to negative end. So that's my second loop here. And then I can add the third loop with the 120 ohm resistor. And it's the same thing, is the positive end connects to the positive end of this resistor, and the negative end connects to the negative end with this resistor. So positive end to positive end, and negative end to negative end. And so it connects like so. And you can see how they all connect together like that. And that's your completed circuit. This one's tricky to build, so definitely if you are feeling confused, get your lab instructor to check it before you continue on and take data. And as before, you have to push down the switch in order to get readings, to get current flowing through the circuit. So here's the third circuit that you're going to build. This one is a combination of resistors in parallel and also resistors in series. So, as before, what I recommend you do is hook up this inner loop first, and once you've got that fully hooked up, then you add the second loop. And as before, I also recommend just unplug everything, start from scratch. That way you're least likely to get confused. So, hooking this up, the inner loop, I'll just move this over here. So I want to go from the positive end of the 12 volts to the switch, as before. And then after the switch, I'm just hooking up this inner loop here. I go to 100 ohms. And after the 100 ohms, from the other end of it, I go to 120 ohms. And after the 120, I go back to the negative end of the power supply. So that's the inner loop, these elements, and now I hook up the 300 ohm resistor across these guys. And you have to be a little careful here, is we want to hook up across the positive end of the 100 and the negative end of the 120. So positive end of the 100, negative end of the 120. So positive to this positive end here, and negative to this end, negative end here. And again, if you're at all confused about this, you ask your lab instructor to come over and check it before you start taking data. So now I'm going to teach you how to use the multimeters to measure the current and the voltage. So this is the first circuit again, and I'm just going to move this guy over here. Here's a multimeter. You will probably have two of these on your desk, and so you're free to use one of them as a voltmeter and one of them as a ammeter exclusively. Now when you want to measure the voltage, you need to hook into these two terminals. You also want to switch the dial to the V with a straight line over it. There's also a V with a squiggle. That's for alternating current. It's not what we're studying today. So you turn to the V with a straight line over it and make sure you're plugged across these two terminals over here. To measure a voltage, it's just a case of you take those two wires and you plug them in across whatever circuit element you're interested in getting the voltage of. So for example, if I want the voltage across this resistor, I just plug my two wires into there. And then when I push down the switch, I should get a number on my screen, which I do. Now, if you happen to see a negative sign on here, it just means you flipped the terminals backward. It's not a big deal. You can just ignore the minus sign and write down the magnitude of what you're reading off of the screen. Likewise, if you are interested in the current coming out of the power supply, you just take those two wires and plug across the power supply terminals, just like so, like that, and then push this down and you should get a reading on your voltmeter. So for voltage, it's fairly straightforward to measure something. You just plug in across whatever it is that you're interested in, push down the switch, and that should give you your voltage. Measuring current is trickier, so let me show you that now. So to measure the current of something, again, you've got a multimeter, and you only need one wire to do this, as I'll show you. Now we want to measure the DC current, so we want the milliamps and amps scale with a straight line over it. There's also milliamps and amps with a squiggly line, but we switch over to the one that has a straight bar over top of it. To measure current, you're going to be plugging in either across these two terminals or these two. These two diagonally are always going to be for larger currents. Most of the time you want to use these two. This will give you the most accurate number. So if you go across here, it's for large currents, which is only really applicable for the second circuit, which I'll show you in a moment. So generally speaking, it's these two terminals that you're going to be interested in. Now, why do I only have one wire here? It's because when we measure the current of something, what we want to do is interrupt the current and then make that go through the meter first before it goes on to where it was supposed to go. So the electricity is coming through this wire into this resistor, for example. I want to interrupt that current, make it go into the circuit, into the ammeter first, and then once it's been through my meter, then it's allowed to continue on to where it was supposed to go. So this wire had been plugged in here. I've said, okay, send that current through my meter first before it's allowed to go where it was supposed to go. And now, when I push the switch down, I'm measuring the current that's going into that resistor because it must go through my meter before it goes through the resistor. So with measuring current, it's always a case of interrupt the current wherever it was supposed to be going, make it go through the meter first. Likewise, with measuring the current coming out of or going into the power supply, it would be a case of, okay, it's headed into the power supply here. I'm going to interrupt that, put it into the meter, and then once it's been into my meter, then it's allowed to continue on to the black plug here on the power supply. And when I push this switch down, now I'm measuring the current going into the power supply because it has to go through my meter before it gets to where it's going. So that's how you measure a current. I'm going to show you this again for the second circuit that we build today, just because it's quite a bit more complicated and it's easier to get confused about it. So I'll show you that as well. So this is the third circuit again. So this is the one where I've got everything hooked up parallel to one another. So everything connects like so, one to the next. So this is a slightly confusing looking circuit, but it is still pretty easy to measure your currents and your voltages. Now remember, with voltage, you've got two wires, and if you're interested in measuring, say, the voltage across this guy in the middle, this resistor, it's just a case of hooking up across the two terminals on that resistor, and then when you push the switch down, you'll measure your voltage directly. So with voltage, just plug in across whatever it is you're interested in. So if you wanted the voltage of this guy, you just put your two wires across these two terminals. Same thing with measuring the voltage of the power supply. Again, it's just as simple as saying, okay, plug in those two wires across the power supply, and then push the switch down. So that gives me the voltage coming out of the entire circuit. Measuring the current, as usual, is just a little bit more confusing. So how do we actually do this? Remember, I said before that what it is that you have to interrupt the current and then force it to go through the meter before it goes on to wherever it was supposed to go. So say, for example, I want the current going into this middle resistor. This is the current that's feeding into it. So I take that, I interrupt it, I put it into here, and then once it's been through my meter, it's allowed to continue to where it was supposed to go. So this connection point had been plugged in here. I interrupted, forced it to go into the meter, and then once it's been through the meter, it's allowed to continue on into the resistor. And now when I push this down, I get the current reading for this one resistor. Now this second circuit is the one where it is possible to blow out your meter to blow out the fuse on your meter if you have hooked up the circuit exactly the way it is listed in the lab manual, which means that instead of this being a 300 ohm resistor, it's a 50 ohm resistor. So if your lab instructor has you building this circuit exactly as in the manual with a 50 ohm resistor, then when you measure the current coming out of or going into the power supply, you have to be careful. That's the one measurement where you may blow out the fuse on your ammeter. To prevent that happening, what you do is, instead of plugging in down here, you plug in up here. This is the less sensitive scale. So I can say, okay, that's the current going back into the power supply. I plug into, I plug into this less sensitive hookup. Instead of this one, I plug in here, and then it's allowed to continue on to the black plug on the power supply. So at that point, I can push this down, and it doesn't matter that this is a 50 ohm resistor. I will not blow out the fuse because I'm on the less sensitive scale. Now, if your lab instructor told you to put a 300 ohm resistor in here instead, then it's actually not possible for you to blow out the fuse. The current coming out of here won't be big enough. So in that case, you can plug in to this more sensitive scale and get a better value, a more exact value. So that's only if you've got a larger resistor here that you can then plug into the sensitive scale, push your switch down, and measure the current directly. If it's the 50 ohm resistor, make sure that you're on the less sensitive scale. Okay, so now I'm going to make one final point about taking measurements. Remember that on the second circuit, if you've got 50 ohms here, then you may be switching between the less sensitive scale and the more sensitive scale when you take current measurements. So I've got this guy propped up. You can do that too if it's comfortable for you. And I just want to show you that if you're on this less sensitive scale, when I push this down, on the screen it says 0.22. That's in amps. Now when you move to the more sensitive scale down here and take a measurement, it now says 225 or 3 or something like that. This is in milliamps. So when you're on the less sensitive, when you're on the more sensitive scale, the number on the screen is milliamps. When you're on the less sensitive scale, it'll be in amps. So just remember to multiply or divide by 1,000 depending on which units you want to use. Also, this is pretty common that you see that number on the screen fluctuating a little bit. Use the largest one. It'll move around. Just take your best estimate on what it is, but use the largest number that you see if it's just moving a little bit in the last few digits. That's pretty normal.